Today's lessons is on pulley and belt systems. The formulas for pulleys is D out over D in is equal to omega in over omega out. Notice it's very similar to the formulas we use for gears, which is equal to torque out over torque in. We don't call them gear ratios because we don't have a gear when we're dealing with a pulley and a belt system. So they're equal, all right? So that means your D out, okay? So our D out is going to be 6, and our D in is 2. So it's going to be 6 over 2, which is going to give us 3, right? That's also going to be equal to our omega in over omega out. Omega in is 30 divided by 10. 30 divided by 10 also gives us 3. That also has to be equal to the torque out over torque in, okay? And we're given that the torque out is 55 foot-pounds and the torque in is 18 1/3. So if you do the math, that'll also give you 3. Okay, so we don't call this gear ratio, but this formula is similar to our gear ratio formula. For sprocket and chain systems, like you'd see on a bicycle, remember we don't call them gears on a bike, we call them sprockets and chains. Okay, contrary to the way most people call them, they're sprockets and chains. We use a similar formula. N out over N in is equal to D out over D in, okay, which is equal to angular velocity out, in over out. Remember, angular velocity is in over out, so it's the opposite, which is equal to torque out over torque in. Okay, so our N out is well, we're not given it here. We're not given the count on here. Our N out is going to be 22, so this one must be 22, and this one must be 11. So basically, that's how the gears work. Well, again, people call them gears, but I shouldn't call them gears on a bicycle. When you're changing speeds on a bike, that's how gears on a bicycle work. Is that basically the speed that you're in is equal to the number of teeth on your out, which is the rear, divided by the number of teeth that you're in. So 22 over 11. That's also going to be equal to the diameter out divided by the diameter in. So that's diameter out is 3. So this is going to be 3 divided by the diameter in, which is 1.5. 3 divided by 1.5 will give you 2, right? Which is also equal to the angular velocity in, which is 90. Divided by angular velocity out. 90 over 45 also gives you 2, which is equal to torque out, which we're given as 120, divided by torque in, which is 60. So that also gives us 2. So let's for a moment compare pulleys to sprockets. All right, pulleys use a belt. Sprockets, like what's on your bicycle, use a chain instead of a belt. Some of the advantages to using a pulley is that pulleys tend to be quiet and they don't require any lubrication, and they're also very inexpensive. Pulleys, sometimes you'll see pulleys on a lawnmower, especially a ride-on lawnmower. You also very often see pulleys inside a car engine, right? Sprockets, like on your bicycle, will never slip, okay? And they're also stronger, so they can deal with much greater torque than pulleys do because they're going to be stronger. One of the drawbacks to pulleys is that pulleys can slip, and when a pulley inside a car engine starts to slip, it starts to get squeaky and noisy. One of my cars is starting to do that. Sprockets, like on your bicycle, are much more expensive. The cost can be higher. They do require lubrication. That's why you need to go ahead and oil the chain on your bicycle. If you have a chain on a garage door opener, you need to go ahead and lubricate that, and they can also be noisy as well. So if you have a chain on a garage door, they're not so desirable if your garage door is, let's say, right underneath your bedroom, because then when somebody opens or closes the garage door, then it's going to be real loud and it could wake you up while you're trying to sleep. So very often, if you have a garage door that's right beneath the bedroom, you might want to use a pulley system because it's much quieter rather than a sprocket system, which is quite a bit noisier.